Welcome back. We will continue section 5.1 and we're going to talk about more problems, more system of equations using the addition and substitution, and we're going to see how we solve these problems and what kind of system, whether it's consistent, inconsistent, one solution, infinitely many solution, or no solution. So we're going to work on some examples and see how it works. So we'll continue. I have a problem here. I have y, the first equation is 3x minus 5. The second equation is 6x minus 2y equals 10. Okay. I'll see here that this equation y is already given here. So I don't have to use addition here, okay? Because I'm given y, they evaluate y. So I can use substitution here. I plug 3x minus 5 here and solve for x. Now let's do that. So 6x minus 2, and I'm going to plug y, which is 3x minus 5, this one here. So I will get here 3x minus 5, 2 minus negative 2 times 3x minus 5 equals 10. Now I have one equation, one variable in one equation. I can solve that. 6x, I distribute the negative 2. Negative 6x minus times minus is plus. And 2 times 5 is 10 equals 10. Okay, 6x minus 6x is 0, so I have 10 equals 10. There is no x here. So what I'm supposed to do? But that equation, the statement is true, 10 is 10, correct. So in this case, I say that this here, the number of solution is infinitely many solution. Why? Because the statement is true. If the statement is true, then I have infinitely many solution. If the statement is false, then I have no solution. Okay? Alright, so that means that the system is consistent, and I have the variables are dependent. So dependent. Question: how can I write this solution? So to write this solution is x and y. Do you remember when I told you how to write it down? And then you write one equation here, such that y equals 3x minus 5. Meaning that in each x, for all x, okay, for all x, let's call that, for all x and y, such that y equals 3x minus 5. So if x is 0, then y is negative 5. If x is 1, 3 minus 5 is negative 2. So for all x, y equals 3x minus 5. Is that clear? Well, the system, I have infinitely many solutions, the system is consistent, and x and y are dependent. Okay, let's get another example. Okay, we want to solve this example. I have the system of equation is 8x minus 4y equals 7. Negative 2x plus y equals 9. Once I'm done with this problem, I need to do some comment on these two examples. Alright, so now what should I do? This is 8 and this is negative 2. So if I multiply this by 4, I get negative 8 and I get rid of x. Does it make sense? So I multiply the second equation by 4. Well, let's write the system, the new system. So I have 8x minus 4y equals 7. And 4 times negative 2 is negative 8x. 4 times y is 4y. And 4 times 9 is 36. Add. So 8 minus 8 is 0. That is cancelled out. Oh, negative 4 plus 4 is 0 as well. So I get 0 equal 7 plus 36 is 43. So now I got a statement, but is 0 equal to 43? No. So the statement is false. Since the statement is false, then I have no solution. So here is no solution. And the system, since no solution, the system is inconsistent. So the system is inconsistent. Okay, let's talk about that. I said that when I have no solution, that means that the two lines are unparallel. And we have learned before that if two lines are unparallel, that means that they have the same slope. So let's test that. So I want to make each equation in terms of y. So let's do that. So here I'm going to subtract, I'm going to subtract 8x. So I have negative 4y, equals negative 8x plus 7. So you see what I did? And now I divide by negative 4. So y equals negative 8 over negative 4, x plus 7 over negative 4. Let's clean that. So I have y equals negative 8 over negative 4 is 2x minus 7 over 4. Therefore, the slope here is 2. So I must get 2 here to make sure that the slope is correct. Okay, here I'm going to do the same thing. I put it in the form y equals mx plus b. So I subtract, or I add 2x to the other side. So I have y equals, when I add the 2x, I get 2x plus 9. Guess what? I have the same slope. When you have the same slope, two lines that have the same slope must be on parallel. Okay, is that clear? So now you have another way to double check your work. This way, in this example, you're going to have the two lines are overlapped. Well, that means that they have same slope and same y-intercept. So let's try that. Let's try that. I'm going to write this form in y equals mx plus b. I must have the same m, same slope, and the same b, or the x and y-intercept. Okay, so let's go and see. I expect to have same slope, same y-intercept. The first equation is beautiful. It's already in the form. And I got that the slope is 3, and y-intercept is negative 5. So I should get the same answer in the second one. Well, let's try that. Here, I'm going to subtract 6x from both sides, so I have negative 2y equals negative 6x plus 10. Okay? Now, let's clean that, so I'm going to divide by negative 2, divide by negative 2, divide by negative 2. Okay, so I have y here. Negative 6 divided by negative 2, negative with negatives cancelled out. 6 divided by 2 is 3x. Plus 10 over negative 2 is minus 5. And guess what? Same. So if I have same slope, same y-intercept, then the two lines are overlapped and I have infinitely many solutions. If I have the same slope, just same slope, therefore the two lines are unparallel because they have different y-intercept, and in this way, here, like here, that must be in this way, and in this way I have no solution. Okay, I hope that this idea illustrates what you have learned about system of equations. The last thing I have to tell you today is an application about that. And this application, I like this application because it's a little challenging, but you will like this idea. We have learned this application before and with one variable. So today we're going to do this application with two variables. Okay. So let's do that. I have a boat. It's traveling the current against the current, against upstream, against the current. Okay, it takes It takes 2 hours to travel 36 miles. And on the return trip, which is downstream, we call it downstream, which is with the current, it takes 1.5 hours. All right, so I need, what's the speed? What's the speed of the boat? And the current. Okay, so now I have two things. The first thing, I have two unknown variables, the speed of the boat and the speed of the current. So let x be the speed of the boat. Then y be the speed of the current. Okay? Let's do this table. I'm going to do this table, and we learned about that before, I think in section 1.3. Okay? So I'm going to take here with wind or with current and against current. Against current. Okay, and now I have to type the distance. Here's the rate and the time. Okay, so let's circle everything I have here. So a boat is traveling upstream against the current. So against the current, which is the second one here, it takes 2 hours. So So the time is 2 hours. Let's write it down here. 2, let's make it in red. I like red. 2 hours. Okay? To travel 36 miles. So the distance is 36 miles. Now let's circle. On the return trip. So what's the distance on the return trip? The same, right? So that must be 36. It takes 1.5 hours. So 1.5 hours. Okay. So when you go with the current, your speed is added. The boat speed is added to the boat of the current. So for this way, with current, there must be the speed of the boat or the rate of the boat plus the rate of the current. But when you are against the current, you subtract the speed of the current from the boat speed. So that would be x minus y. Now, I'm going to write my system. My system here, I know that the distance is rate times time, d equals rt. Okay, so my system is like that. 36 is this times that. Is 1.5 times x plus y. And the second equation, 36 again, equal 2, there's 2, times x minus y. Here's my system. And now I need to solve for x and y. Alright, so I think this is clear, and I don't think it's hard, but let's work in that. So I have the easiest way to work in that is to divide both sides by 1.5. So that would make it easier. So if I do that, I have 36 divided by 1.5. That would be 36 divided by 1.5. Would be 24. 24 equal x plus y, and 36 divided by 2 is 18 equals x minus y. Okay? Alright, so now we're going to use addition. If I add, okay, I'll get rid of y. So let's add these two together. So here, 24 and 18 is 2, and this is 2 plus 1 is 4, equals y and negative y is cancelled out. I have 2x. Divided by 2, I have x is 21. Now, I am going to evaluate this here. I have 24 equals x plus y. You see how easy that is. So you don't have to go to this one. So that would be easier. So 24 equals x is 21 plus y. We subtract 21 from both sides, so I get y equal 3. Therefore, the speed of the current is 3. So here this is equal 3, and the speed of the boat equals 21. Okay, then my solution is 21 and 3. One solution, consistent, and the variables are independent. Thank you so much for today, and see you in the next section. Thank you.